Hello, in this video I'm going to do the previous example again, except I'm going to do it over a restricted domain. So I'm going to solve 2 cos 2x plus root 3 equals 0 for x is between 0 and 2 pi. Alright, then I'm going to pull out the cas and I'm going to show you how to get the general solution and the domain restricted solution to check if we're correct. So just like the previous example, the first thing to do here is our algebra. Rearranging this equation, we get cos 2x is minus root 3 on 2. And once again, our key angle is going to be equal to, well, cos of 30 degrees is root 3 on 2, and that's the same as pi on 6. Same as the previous example, we know that cos is negative here and here, so we know that 2x equals pi minus pi on 6, or pi plus pi on 6. Alrighty, now I'm going to write 2x equals 5 pi on 6, and I'm going to put a comma here, and 7 pi on 6. So this is the working we did before, but now we have to consider this restricted domain here. So what I like to do, it's a bit of a trick, it's a bit of a shortcut, but it works. I take the coefficient of x and I multiply the numbers in the domain by that coefficient. So here the coefficient's 2, so it's kind of like stretching out the domain. I stretch it out, and then once I'm done I put it back. So I've stretched out the domain. Now what I need to do is keep adding 2 pi to each of these numbers until I hit 4 pi. So let's keep adding 2 pi. Well, I'll make a quick note that 2 pi is equal to 12 pi on 6, right? So we're going to keep adding 12 pi on 6 until we kind of hit this 4 pi, like the wall, 4 pi, we're going to hit it. Okay, so 5 pi on 6 plus 12 pi on 6 is 17 pi on 6, which is less than 3 pi. 7 pi on 6 plus 12 pi on 6 is 19 pi on 6. So that's a little over 3 pi. 17 pi on 6 plus 12 pi on 6 is 29 pi on 6. Yep, we can see that we've gone over 4 pi, because 4 pi is 24 pi on 6. We've gone up to 29 pi on 6. Let's cross that one out. These are our answers, almost, except we need to divide everything by 2. So x equals 5 pi on 12, 7 pi on 12, 17 pi on 12, and 19 pi on 12. And there's our answer. And you'll notice that it doesn't exceed 2 pi, because 19 pi on 12 is a bit less than 2 pi. That's all well and good, but why should you believe me that that's the answer? Here's our answer there. I'm going to show you how to check it on your cas, and we're going to use the zeros function. I really like the zeros function for trig values because it's a bit neater. So you could use the solve function, but you have to like scroll across and it's not as nice. I'll show you what I mean. Let's make a new document. Let's add a calculator. Alright, so first, as I promised before, let's find the general solution to this. So I'll do it with solve, and I'll show you the difference between what the solve function does and what the zeros function does. So let's solve 2 times cos of 2 times x. So you should be hopefully twice as quick as I am with the calculator right now, because you're going to have an exam. The quicker you are with the calculator, the better. And that equals 0. Alright, so this is going to give us our general solution, and we're solving for x. Let's solve that. Yep, that's the general solution we had in the previous video. So if you look for part 1, instead of k, they've chosen this bold n1, but that was one of the answers we came up with when we factorized and took out the pi. So that's good. I'll show you how to do it with the zeros command. I like the zeros command, and I'll show you why. It's just a bit neater. So you don't type equals 0, you put the stuff in, and the zeros command figures out what values make the stuff that you put in 0. And it's particularly good for trig values. Root 3, and we still have to put the argument in, because the argument is x. Let's see what it says. There we are. It gives the same answer, but see how it's got the curly brackets and the comma? So if you have like 10 answers, it will go like x equals blah blah blah, or blah blah blah, or blah blah blah, or blah blah blah, and you have to scroll across. Here, it just lists them out. It's really neat. So I'll show you this using the zeros function. So it's the same solve. So we're going to use zeros. It's the same function, but we put in our usual domain restriction. And the way we do that is we click Control, and we put in that little bar there. And our domain restriction is 0 to 2 pi. So 0, we press Control, we get the equals, whoops, hit that one, yep. 0 to 2 pi, I'm going to enter that, x, Control, it's being a bit iffy, Control, there we go, okay, put in that symbol again, 2 times pi is over here. Alright, look at that. Look how much nicer the zeros function looks. Let's compare that with the solve function. So I'm going to change it. We're going to go over here. We're going to use equals 0, and we're going to change this word from zeros to solve. And we're going to solve it over the domain. So solve, S-O-L-V-E, enter. See that? So if you had like another 4 solutions, you would have to scroll across. That's far more clear. So I can see that that's correct. I'm going to give myself a tick. In the next video, yes, there is another video, I'm going to do a trickier example. Unfortunately, the book doesn't have any of these, but you do need to know them. You do need to know this next example. And if you have been, thank you for watching.